This video is for the complex intersecting lines and angle measures. This is going to be lesson 3.3. Okay, so now we're moving beyond just the transversals. So now we've got a few different setups here. So BD is a straight line. First question says, what is the measure of BOC? So I'm going to try to do these in different colors. So BOC would be this angle right here. Okay, so if we have a straight line, that means these two angles here are going to add up to 180 degrees. So angle DOC, DOC, and angle BOC are a linear pair, meaning they add up to 180 degrees. So I can do 180 degrees minus the 55 degrees that we know, and that gives me 105 degrees. That's the measure of angle BOC. All right, what's the measure of AOD? So AOD would be this one here. So same thing. This angle and this angle are a linear pair. So angle AOD and angle AOB are a linear pair. So I could do 180 degrees minus what we know, 132 degrees, and that would give me 48 degrees, and that would be the measure of angle AOD. All right, and then what's the measure of AOC? So this one, AOC. So that's that angle there. So we know what this one is. AOD is 48 degrees. Sorry, that degree sign looks a little wonky there. And so AOC would be adding those two together. 48 degrees plus 55 degrees equals 103 degrees. And that equals the measure of angle AOC. So you just kind of have to work your way through it. All right, the next one, AD, is a straight line. What's the measure of BOC? So BOC, that's this angle here. So we're no longer a linear pair, but we're supplementary angles. These three angles, because the base is a straight line, would add up to 180 degrees. So I can take 180 degrees, subtract the two angles that I know, and get 59 degrees. That would be the measure of this piece, and those are supplementary angles. Okay. BE is a straight line. AD is a straight line. So what's the measure of AOE? That would be this one. Okay, so we've got a linear pair here. So I could do 180 minus 55, and that would give me 125 degrees, and that would be the measure of angle AOE, because we have a linear pair there. So what's the measure of DOE? Okay, so this one we have to look at really carefully. What we've got, this line is straight and this line is straight. So when we have two straight lines that intersect, we have vertical angles that are formed. Okay, it's hard to see. This extra little piece is there to throw you off, but you've got vertical angles. And so if this one is 55, then this one would be 55. And I'm going to go ahead and label this one in here too. It always helps to label your diagram. So the measure of angle DOE is 55 degrees. And those are vertical angles. All right, and then finally, what's the measure of COD? So COD would be this here, that section. Okay, so COD, we've got this straight line here, so these are supplementary angles, meaning these three angles are going to add up to 180. So I can take 180, subtract the measurements that I know, and I get 95 degrees, and those are supplementary angles. Okay, triangle sum theorem. The sum of the three interior angles of any triangle is 180 degrees. So, first one here. Find the measure of ACD. C is this center point here. So, ACD is that one. So, what we've got here, we've actually got vertical angles. Okay? So, vertical angles are congruent, so we can set those equal to each other. So menu 3(1), 12x plus 15 equals 20x minus 6, comma x, and we get x equals 2.625. We're going to leave it like that, and that's okay. But that's just what x equals. If I want to know what the measure of ACD is, I'm going to plug that 2.625 in for that x. Okay. And so I get 46.5 degrees. That's the actual angle measurement. All right, then we're going to find the measure of FDG. FDG, so that's this one here. And so what we've got there is we've got a linear pair. So this angle and this angle are a linear pair. So we can do 180 minus 121 equals 59 degrees. All right, and those are a linear pair. So I'm going to go ahead. All right, 59 degrees there. I'm not going to write that one in. You just have to write it kind of tiny that this one is 46.5. All right, find the measure of DAC. So again, C is that center point. So there's DAC. Okay, this is triangle sum theorem. So we need to know this angle measure before we can find this angle measure. Well, these two angles here are vertical. So that's going to be 59 degrees. And so that angle is CDA. So the measure of angle CDA is going to equal 59 degrees. And that's because of vertical angles. Okay, so now we can use the triangle sum theorem. All three angles in a triangle are going to add up to 180 degrees. So we know two of these angles. So I can do 180 minus 59 minus 46.5, and that will give me 74.5 degrees. And that is equal to the measure of angle DAC. And that's the triangle sum theorem. Okay, now we got a lot to do. We're going to find the measures of angle 1 through 8. Now I put these in a specific order because sometimes you have to find others before you can do, so we may need to find 7 before we can do 5 and so on. All right, so angle 7. So angle 7 forms a linear pair with this 129 degrees. So we can do 180 minus 129 equals 51 degrees. And that is a linear pair. That's how I solved it. Angle 8, well, now that we know that this one is 51 degrees, all three angles in a triangle add up to 180 degrees. So I can subtract the two measurements that I know and get 85 degrees. And I did that using triangle sum theorem. So that one was 85 degrees. All right, angle 5. Angle 5 and angle 7 are vertical angles. So if 7 is 51, then 5 is 51 degrees. And that's because of vertical angles. Number 6, we've got another triangle, so we can use triangle sum theorem again. Minus 64 minus 51 gives me 65 degrees, and that is triangle sum theorem. Okay, so that one was, it's kind of hard to fit in there, 65 degrees. Angle 6 and angle 2 are vertical angles, so if 6 measures 65, then angle 2 is going to measure 65 degrees. And that's vertical angles. So this one was 65 degrees. All right, angle 3, we kind of got to switch modes here. So angle 3 and this 48 are vertical angles. So angle 3 is going to measure 48 degrees because of vertical angles. So this one is 48 degrees. Now we can find angle 1. We've got another triangle, so we can use triangle sum theorem. 180 minus 65 minus 48 equals 67 degrees. And that's triangle sum theorem. And then finally angle 4. Angle 3 and angle 4 are a linear pair. So we can do 180 degrees minus 48 degrees, and that gives me 132 degrees. And again, that is a linear pair. So sometimes you have to just work your way through it. All right, one more big one. Find the measures of angles 2 through 10. So here's some good information. PQ and RS, these two are parallel. That's good information to know, because that means this line is a transversal and this line could also be considered transversal. Also, LM to NO are perpendicular. That means each of these square angles here is 90 degrees. And then the measure of angle 1 is 32 degrees. So right off the bat, I know angle 4 is 32 degrees. Vertical angles. Just knock them out. 32 degrees. 1 and 2 are a linear pair, so I can do 180 degrees minus 32 degrees, and that gives me 148 degrees. 2 and 3 are vertical angles, which means 3 is going to be 148 degrees as well. So sometimes you can go through these pretty quick. Okay, it jumps to 9. So here's what we know. Let's ignore this line. Okay, this big angle right here, let's name this angle A. Angle A and angle 2, angle A and angle 2, angle A and angle 2, again, ignoring NO, are corresponding angles. So if this is 148 degrees, this big thing is 148 degrees. We know that this part of the angle right here measures 90 degrees. So we know that angle 9 plus 90 degrees has to equal, angle 9 plus 90 degrees has to equal 148 degrees, which means angle 9 is going to be 58 degrees. So sometimes you have to look at these a little closely to make sure you're answering what it's asking. Okay, now we're moving to 10. Well, 9 and 10 are what we call complementary angles. These two angles together are going to add up. Angle 9 plus angle 10 would equal 90 degrees because those lines are perpendicular. Well, we know angle 9 is 58 degrees plus angle 10 equals 90 degrees, so we can just do 90 minus 58, and that gives us 32 degrees. So that one would be 32. This one was 58. And that's important, okay? Because now ignoring this line, angle 7 and angle 9, so look at this line here and our parallels. Angle 7 and angle 9 are corresponding. So if this one is 58 degrees, then angle 7 is 58 degrees. Now we can knock the rest of these out really quick. 7 and 5 are vertical angles. So angle 5 is going to measure 58 degrees. 7 and 8 are a linear pair. So we just take 180 and subtract 58 degrees, and we get 122 degrees. 8 and 6 are vertical, which means 6 has to be 122 degrees as well. So they can get pretty complex, but if you take them just a piece at a time, they're not too bad.